Okay, so watching you guys solve this, you guys had way too much marker in your hand and way too little calculator in your hand. Again, all of this is done on my calculator. For lunch, there's 2 more problems, just like this, that you can do with your calculator, and I have the answer key right behind it. I think they're the 2015 and 2016 problems from the AP. This is an AP-like problem from the book. Okay, so first thing that you could have done on A, could you type it in speed equals square root of this dx dt squared plus dyt squared and have it on your main part of your calculator by plugging in 3? So could I put it in right here and start with the square root of stuff? Could I do that? I was about to do that, and then I quickly read B. And what does B ask me to do? Arc length, which is the same thing as A, but do I plug in 3? No, I plug in T or X or whatever variable you want, and then I need to integrate it. So instead of typing into the main screen, the first thing I did was that. First thing I did, and I think a lot of you did not do that. A lot of you started like writing stuff down rather than that. So I typed that in, and then what did I do for A? What? Second calc, trace, and got it. Hello, hello, hello. That looks good, right? There's no sound, but the microphone's going. Okay, good. So my speed was 12. Then I'm already ready for B, and I just did second calculate integral, and I got 59.7. A and B, I'm done, just like that. And it all came from typing in the speed equation on my y equals. Remember, x is really t in this case. So it's a parametric setup, but I type it in rectangularly. Okay? And looking around the boards, I do get the 12. And I do get, I see someone have a 12, and I think I see someone that has a 59. What I also see on the boards is a lot of extra math. Okay? So I think you got some answers right, but you guys spent a lot more time expanding out or trying to simplify when you didn't need to. Okay? Now, C. It does not care about the total length that you went. Last period I came up with this idea. So I'm going to kind of draw over this. On a map, we started at 1, 2, 1, 2, 3. That's where you start. That's from the 2, 3. And within those 5 hours, you went a total of 59.7. So I want you to think, this is not to scale, but I want you to think this radius is 59.7. Inside those 5 hours or 5 seconds or whatever it is, that's how far I traveled. Does it mean I'm on the circle? My arc length was 59.7. I started at 2, 3. Does that mean I ended, put a little smiley face, does that mean I ended due east 59.7? Could I have? Yeah, maybe. Could I have been due north or south or west or directly northwest? I could have been there. Most likely I did not run in a straight line the whole way. And in fact, I know I didn't because, do you agree, these guys here change over time. There's no like dx dt is 2 or dx dt is 0. Both guys are changing. So, more likely, this is what happened to my guy. There I am. I'm within the circle. How long is the red? The length of the, sorry, that looks really long. How long's the red? 59.7. Are you guys okay with that? So I can tell you I wiggle wobbled inside the circle and I'm somewhere within there. The envision I had for it is, imagine if someone breaks out of jail and they travel for 5 hours, but secretively they didn't know it. You put a little Fitbit on their waistband. And so, running away from jail for 5 hours, and you're recording their Fitbit mileage, and it's on the computer, and after the 5 hours they go to bed and they sleep because they think they're hiding in a safe spot, and your Fitbit recorder on your computer says they traveled 59.7 miles. Okay, could you take a map of centered around the jail at 2,3, make a radius that's 59.7 around, build that green? Could you cut that out of the map, and it's a fact that the person is inside there? And then that's where you would start your search. Okay? And he is somewhere inside, he or she is somewhere inside that circular boundary region, because they did not pass over that circle, because you know that's the max distance away. Cool? Next question is saying, how far north did the guy go? Y3 is only about up and down, has nothing to do with the dx dt. So if you think last week about the projectiles, when we shoot the ball at an angle, there's the horizontal distance and the vertical distance. In this problem, I'm only talking about vertical distance for letter C. So it does nothing about dx dt, it's only about dy dt. So now what I put in on my calculator is only the dy dt. So now I have the dy dt up, and it looks like you guys have that on your board, but then you guys try to solve that on your board, and you're thinking like trig sum, which is correct. If there is no calculator, you should be doing some sort of trig sum. But I can integrate it on my calculator. Everything's on my calculator. So I integrate that on the calculator. What does that mean? What does that answer there in my light blue mean? 3 seconds have passed, and I've traveled 42 feet, 42 miles, whatever, 42 units north. Where did I start? At 2,3, which number do I care about? 3. So if I started at 2,3, I am now at 45.13. You guys okay with that? That has broken down the components. I ignored all of the x and I focused on the y only. Okay? Next question. There's a point where the tangent line is vertical. So if you go back to my little red design here, there's a lot of places where it's vertical. Looks like I went vertical there. There's a lot of places where I went vertical. In this story, it's telling me I only went vertical once. So let's say that Fitbit recorder also tracks direction. So it, hey, it traveled 59 miles. It also says northeast, northwest, north, south, northeast, northwest. It's kind of like has the rear view mirror tracker on it. And they know when the bad guy went due north or due south. Okay? And it happened once. What do you care about when that happens? If the slope is undefined, that's when the bottom is 0. So I need to figure out when dx dt equals 0. Then that means I have an undefined total slope, and that means I walk north or south. So, next part, I type in the dx dt portion in my third line. I graph it, and I find it's 0. 0.55394. So 0.55 seconds later, the dx dt is 0. And again, it's sometimes you get lost in what things represent. Dx dt in this represented is by y. Are you guys okay with that? This is like there's so many different letters going on. What does x represent really? Time. What does y represent in this case? That. And what is that guy? My dx dt. So at time 0.55, my quote-unquote y, which is this, which is my dx dt, is 0, which then means my real slope is undefined. So that's the time it's undefined. And it says, okay, find the acceleration vector at that point. So what do I need to do with that time? Call it 0.55. What do I need to do with it? I know the time is 0.55, and I need the second derivative of x and the second derivative of y at 0.55. What would I do on my calculator? Here's my guys. Let's see what I got. Dark blue is speed, light blue is my dy dt, and orange is my dx dt. And they know at 0.55 is when I am going due north or due south. And it wants my acceleration at that moment. What do I need to do? Evan. Ooh, okay. If you do second calculate slope of dark blue, you are finding what? Acceleration overall. You're finding the combined acceleration of me traveling northeast or northwest. It doesn't want that. What does it want broken down? I want my dx dt second derivative, dy dt second. So I want it as components. So do I need the dark blue? Do you see why I turned that off? Because I'm still looking in the component world. So now I'm going to look at light blue and orange. But I like what Evan said. He said, look at light blue and orange and find the slopes of those. And here's another weird thing. I'm finding the slopes of those, which might make you think you're in like the blue world. But what am I graphing right now? The blue world. So if I find the slopes of the blue world, am I going down to the green world, which is acceleration? Okay. So I could go to second calculate slope, which is 6, and I will do it here at 0.55. Okay, so now, okay, what do we got here? X equals 0.55, that is my time. Y equals 14.9, what's that represent? Is that the dy dt or the second derivative? That's the dy dt. And the dy dx here is actually the derivative of the derivative, which is the what I think I needed, which is the acceleration. That's one part. And then I would need to do second calculate. Let's try that again. Okay. Second. Nope. Good for us. Second. All right. I would then do second calculate and do the same thing for the orange. And I have, I think it just started to do it. But I have it here. So look, I have the orange and the blue. If it wanted the velocity vector at that moment, it would have been 0, 14.9. This should make sense. If that's the velocity vector, which way am I moving? Up, which is due north. Remember the question said, when am I moving vertical? Okay, so if I was drawing that like red path idea, it would have been, there was one moment where I was going vertical slope, and this happened to be a due north slope because it's 0, 14.9. And then my acceleration was negative 2.216 and negative 0.3344, which means I'm getting accelerating to the bottom left from there. Okay? Do you see, and I did this on purpose with all of the pictures of everything was calculator. Okay? So, not now, but at lunch you can do the following. 2015, notice how it's yes calculator. And 2016, which is yes calculator. Exact same flow. You're going to read stuff about when am I going undefined slope? When am I a horizontal slope. Find the speed, find the distance total, which is arc length. Find the horizontal distance, find the vertical distance where you only care about one of the pieces. Okay, Keone in the back has a question. What's up? Question 1 is a test for parametric going to be entirely calculator? AP, 99% of the time, the parametric question on the AP test is yes calculator. It's normally number 2 or 3. No, sorry, it's normally number 2 on the AP test, which is a calculator question. So for me, in a week, it will be a calculator question. So you need to know how to manipulate the calculator parametric question, but I'm using rectangular to solve it. Correct on that question. You have another question?